All right, so today we're talking about complex numbers, and we are finally teaching you how to deal with the situation when you get these negative square roots. Up to this point, we've just told you, right, that there's no real solutions and move on. The problem is, in the real world, we run into a lot of situations where we have these equations that don't have real solutions. And it got us to where we were stuck. We could get really far in the problem, and then we would get stuck because of these negative square roots. And one of the things that mathematicians realized is like this square root of negative 81. If you were to factor that down, you would factor that down to be negative 9 and 9. This 9 turns into 3 and 3. This 9 turns into 3 and negative 3. Well, then they realized that we can take that negative 3 and turn it into a 3 and a negative 1. So quickly, we recognized, hey, square root of negative 81, that just becomes 9 times the square root of negative 1. And same with the square root of negative 12. They realized I can break 12 down, negative 12 down into negative 2 and 6 down into 2 and 3. And this negative 2, they could break it into positive 2 and negative 1. So when they would rewrite the square root, they would have negative 1 times 2 times 2 times 3. So they could pull those 2's out, but they would always end up stuck with this negative 1 on the inside. However they simplified, there was always this piece right here left over. So they decided to give it a name. They decided to call that piece I. That square root of negative 1 has its own mathematical representation in the letter I. So instead of our problem, the square root of 81, instead of saying we can't do anything, we started saying, you know what, let's call that 9I. Let's take that square root of negative 1 and let's just turn it into a variable I. And the cool thing about that is that variable, we do math with that variable the same way as any other variable. Like if I want to add 9i plus 7i, that's just 16i. We treat it like it's an x. But in this case, we actually know what x is. X represents a number. It just represents a number that doesn't exist in the real world, that causes some issues when we are trying to do math. But it does represent something that we know, the square root of negative 1. So because it acts like a variable, this first example, it shows you that you can actually add these numbers together. So if I have 2 plus 3i and I want to add that to 10 minus 7i, I take the 2 and the 10, those can add together and be 12. And then I can take the 3i and combine that with the minus 7i to get negative 4i. So when you add them together, you just treat them like any other x that you would be working with. When you multiply them together, a little bit more interesting stuff happens. So if I were to have like 4x multiplied by 5x, you would tell me 4 times 5 is 20, x times x is x squared, which is true. When I take 4i and I multiply that by 5i, I get the same answer. 4 times 5 is 20, I times I is I squared. But something interesting happens because we don't know what x is. So when I get to this point, x squared, I'm stuck. But I know what I is. So I squared, that means the square root of negative 1 multiplied by the square root of negative 1, which turns into a nice number. It turns into negative 1. So anytime I see an I squared, I can replace it with negative 1. So this becomes 20 multiplied by negative 1, which just becomes negative 20. So it acts like a variable in a lot of ways, but we have extra benefits to it because we do know what we know what I is. We know it's not just some random number. It is a specific number that we know. So in your examples, 1 through 4, I'm just going to go through these really quick. They're just examples of what happens when you add and subtract and multiply this together. Number 1, you already saw something similar. 4 plus 8i plus 6 minus 10i. You add the 4 and the 6 and you get 10. The 8i's add together with the minus 10i's and become a negative 2i. And I would stop right there. Number 2 has this negative in the middle. So I have 2 minus I, but then I have to distribute that negative. So I would rewrite this one, 2 minus I minus 3 minus 3i. And then I just combine like terms. 2 and negative 3 become negative 1. Negative I and negative 3i become negative 4i. And that would be my final, that's as far as I can simplify that one. Number 3 wants me to multiply. So just like we did earlier, we do the negative 9 and the 3. That gives me negative 27. And I times I gives me I squared. Normally with a variable, we would be done. But we know that I squared actually equals negative 1. So this becomes negative 27 times negative 1. So really, it just changes that negative 27 to a positive 27, which is kind of a nice shortcut, right? Anywhere you see a I squared, it turns the number, it changes the sign. So number 4, this one is a little bit more involved because we have to multiply 2 parentheses together. So I do 2 times 6 and get 12. I do 2 times negative 4i and get negative 8i. Then I take 5i and multiply it by 6. That's 30i. And then I take 5i and multiply it by negative 4i, and I get negative 20i squared. So my i's go together in the middle. Those become 22i. And this negative 20i squared, remember I squared can be replaced with a negative 1. So that negative 20 actually turns into a positive 20. And now I can combine that with my 12, and I get 32. And I usually try to put the regular, the normal number without the I in the front. I usually put I at the very end. So I would put that 32 in front. It doesn't matter if it's at the end, but out of habit, I put the I at the end. Okay, number 5. A few more interesting things and then some application to more.
Okay, you have a meeting down in Lecture Hall 100 that is starting right now. GSA, you have a meeting in Lecture Hall 100 that is starting right now.
It's so nice of them to interrupt. These apply a little bit more to the chapter that we're doing right now. So first of all, I to the 7th power, something cool just happens. Because if I have I, that just means the square root of negative 1. If I have I squared, that was the square root of negative 1 times the square root of negative 1, which turned into negative 1. If I have I cubed, well, that's I squared, negative 1, multiplied by another I. So that just turns into negative I. I to the 4th is negative I multiplied by another I. And that just turns into negative, or sorry, not negative 1. That's going to turn into positive 1 because the i's multiply together to be a positive, or to be a negative 1, and they multiply by that negative, and they become a positive 1. So now if I take I to the 5th, I start over. I to the 5th is just 1 multiplied by I, so that's just I. I to the 6th becomes the same as I squared. I to the 7th is the same as I to the 3rd. I to the 8th is the same as I to the 4th. So the pattern just repeats every 4 numbers. So I to the 7th is the same as I to the 3rd power, which we said was negative I. Not something I'm going to test you on this year, but it is something that the ACT likes to bring up, and it's something I think you should be able to see. The second example for number 5 is square root of negative 25. So I can break negative 25. That can break up into 5 times 5 times negative 1. We know those can come out and just become 5. So that becomes 5 square root negative 1. Well, we decided to give square root of negative 1 a name. It's I. So my answer becomes 5i, which quickly you kind of pick up on a shortcut. I can replace the negative on the inside. I can just get rid of it and put an I on the outside. For example, look at this fourth example right here. Square root of negative 104. For just a minute, let's just deal with the square root of positive 104. Well, that's 2 times 52, which is 2 times 26, which is 2 times 13, and that's as much as it's going to simplify. So that becomes the square root of 2 times 2 times 2 times 13, which becomes 2 root 26. But it wasn't a positive 104. It was a negative 104. All I have to do is add an I to take care of that negative. Everything else is exactly the same, but instead of just being 2 root 26, it's 2 root 26, and you have an I. I will usually move the I right here in front of the root. I kind of sandwich it in between because I don't want to make the mistake of thinking the I is under my square root. So I usually put the I in the middle. It doesn't matter where it goes. It all means the same thing. Okay, so anytime you see a square root of a negative, the square root of negative 36, well, the square root of 36 is 6. But I have to deal with this negative, so I just add an I. The square root of negative 12, well, the square root of positive 12 is 2 root 3. Well, all I have to do is replace that negative with an I. So it becomes 2 root 3 with an I, or 2i root 3. So anytime you have a negative, deal with it really quickly. Pretend it's not there, and then add an I to your answer. All right? So let's use that now in our quadratic formula, because this is where I came up the most, right? So on this first quadratic question, A is equal to 1, B is equal to 10, C is equal to 29. So x equals negative 10 plus minus the square root of 10 squared minus 4 times 1 times 29, all divided by 2 times 1. So when I plug this inside part in my calculator, which you are supposed to do first, right? That becomes x equals what? Negative 10 plus or minus the square root of negative 16, all divided by 2. Now, normally, in the past, we would say no real solutions. But now, I know that I can take this square root of negative 16, and I can deal with that part. The square root of negative 16 is the same thing as the square root of 16, which becomes 4. But it's not a positive 16, it's a negative 16, so I have to add an I to it. So all I do is replace that square root of negative 16 with 4i, all divided by 2. And conveniently enough, it's nice because both of these divide by 2. So negative 10 divided by 2 is negative 5, plus or minus. 4 divided by 2 is 2, and I have an I still. Please don't try to add and subtract negative 5 and 2i. They don't add together because one of them has an I and one of them does not have an I. So you can't combine those. This right here would be my final answer. All right? So let's try this one more time, and then I will let you practice these on your own. So A for this last example is 1, B is negative 8, and C is a great big 65. So when I write my formula, x equals negative 8 plus or minus the square root. I did not give myself enough room. Hold on. Let's move some things. Give ourselves some more room. So x equals -8 plus or minus -8 squared minus 4 parenthesis 1 parenthesis 65. Yikes, that's a big number. All divided by 2 times a, which is 1. So x equals -8 becomes a +8 plus or minus the square root. I'm going to follow Mr. Reed's steps, and I'm going to plug this part into my calculator. And I get something -196. And all of that is divided by 2. So I cannot say no real solutions anymore because Mr. Reed taught me what to do. So let's deal with this negative square root. So the -196 is the same as 196. Square root of 196, I believe, is 14. So the square root of -196 is also 14, but I have to add an I to it because it's a -196. So my problem becomes 8 plus or minus 14i, all divided by 2. And, well, that's nice again. 8 divides by 2. That's 4. Plus minus 14 divides by 2. That's 7. And I have an I still. And I can't add those together because one is an I, one is not. So that would be my final answer.